Good morning, everyone. Today, I am going to introduce you to a fundamental concept in computer science, which we call it as data structures. So, the data structures are essential building blocks used to organize, manage, and store data efficiently in a computer so that it can be accessed and modified effectively. So, what are data structures? A data structure is a particular way of organizing the data in a computer in order to use it in an efficient way. So, the choice of data structure can significantly affect the performance of a program or an algorithm. Common operations like searching, inserting, deleting, and updating data are all impacted by the data structures which we used in the memory. So, the term data structure is used to describe the way in which the data are stored in the memory. So, algorithm. So, usually a program means it's a combination of an algorithm and a data structure. So why we need data structure? So next concept is why we need data structure. So the data structures are critical for crafting efficient algorithms. So they help in optimizing the performance, which means certain data structures allow quicker access and manipulation of data for better resource management and for reusability and modularity. So there are some types of data structures which can be used for storing the data in a memory. So the type of data structures can be broadly classified into two categories: primitive and non-primitive. Primitive data structure. So what is primitive data structure? So they are the basic building blocks of data manipulation. That means that the basic data structure which directly operates on a particular machine instructions. So we are having like integer, float, character, pointers. They are all of the primitive data structures. And next is, that means these are all very simple data types which is provided by the, that means integer, float, character, pointers are simple data types provided by the programming language and are typically used to represent a single value. So all these integer, float, character, points comes under primitive data structure. Next is non-primitive data structure. So non-primitive data structures are more complex, and that can be divided. Again, we can divide the non-primitive into linear data structure and non-linear data structure. So this is the type of data structures: primitive, non-primitive. So in primitive we are having integer, float, character and pointers, and in non-primitive we are having array, list, files, and again list having linear list and non-linear. Again, linear list means we are having stack and queues. Non-linear list means we are having graphs and trees. So first we will look on to the non-primitive data types in that linear data structure. So linear data structure means the data can be accessed in a sequential manner. So what are all the linear data structure means? We are having arrays, linked list, stack, queues, all those. That means in the array or in the linked list or in the stacks or in the queues, we can able to access the data in a sequential manner. That means we can able to access the data in one by one fashion. So array, you all know what is meant by an array. So array means it's a collection of elements which is identified by a particular index or a key, and the arrays are useful for storing multiple items of the same data type. So next is the linked list. So linked list, it's a sequence of elements where each element point to the next. So in the linked list, again we are having types of linked list as singly, doubly and circular linked list, which we will see in the later classes. And next is the stack. So it's a collection of element that follows the last in first out. So the stack concept is the element which is inserted at the last can be taken as the element which is inserted at the last will be taken as the first element. The element which is inserted at first, we can able to take that element only at last. So last in, first out is the stack principle, and q is the vice versa of stack, that is first come first serve. So the element which is put first can be taken as the first element as out. So that is based on first in first out principle. And so this is the linear, and in non-linear data structures means we can able to access the data in a non-linear fashion. That means the data cannot be accessed in a consecutive manner. So for examples are the trees, graphs are the major non-linear data structure. Tree means it's a hierarchical structure with the root element and a sub element. Root element we call it as a parent node, and the sub element we call it as a children, that which will forms a parent child relationship. So next is a graph. A graph means it's a set of node, that means it has set of vertices which is connected by the edges. So again we can have the graphs can be a directed graph or the undirected graph. So these are the basic data types. So in the video we had seen what is meant by a data structure and what are the types of data structure. So major two types of data structures are primitive and non-primitive data structures. So okay, in the next class we will discuss about what is meant by ADT, that is abstract data type. So I said it's a linear and non-linear. So again that can be as a contiguous and non-contiguous. Contiguous means it's a continuous memory allocation will be given for the data. Non-contiguous means data will be scattered in the memory, but still we can have a link between the data. So this is what the basics of data structure. Okay, thank you.